so many things at the same time. Alright, I want to present this work, selling information in competitive environments, in 2 minutes. That's what I'm gonna do. So we are gonna set up a timer. First of all, fuck time. So what is the abstract saying? I don't think they are gonna read the abstract because it's so many lines and we have only 2 minutes. I don't even have time to read. Data buyers compete in a game of incomplete information about which a single data seller owns some pay of relevant information. The seller faces a joint information and mechanism design problem, deciding which information to sell while eliciting buyers' types and imposing payments. We drive the welfare and revenue optimal mechanism for a class of games with binary actions and states. Our results highlight the critical properties of selling information in competitive environments. Negative externalities arising from buyers' competition increase the profitability of recommendation. Recommending the correct action to one buyer exclusively for the buyers to follow the seller's recommendation. The degree of exclusivity must be limited. The buyer's obedience constraint also reduce the distortion in allocation of information introduced by monopolists. The buyer's obedience constraint also reduce the allocation. Yeah, but what is the for the buyers? What is the difference of 2 and 3? The buyer's obedience constraint. As competition becomes fiercer, the limitations become more severe, weakening the impact of market power on optimal allocation of information. These limitations become more severe. So finding the optimal action for revenue and welfare. What do we want to show? We come up with a model for this paper. We are gonna come up with a model to sell information through auctions to the firms that are in competition and through an information/mechanism design modeling. And we want to show how this we want to find these optimal auctions, and we also want to tell how they change when we change the intensity of the competition. So you can see that figure 1, welfare maximizing recommendation rule from proposition 6 with 2 buyers. So the figure on the left is alpha 2 over 3, the figure on the right is alpha over 3 over 2. The labeling, so it increases the exclusive area will decrease. Well, exclusive area will increase actually. Yes, because it makes sense to send exclusive, yeah. And there are areas that you actually send information to nobody. In each region, we get the set of buyers who are recommended the correct action, a higher value, and then the buyer 1. This curve. Equally likely ex ante. So the 2 states are equally likely to ex ante. So the median of. Alright. So yeah, the thing is that the abstract sounds very general, and saying what these 1 and 2 mean in the main in the result. I couldn't add all the results. I didn't want to talk about because it's just 2 minutes. So let's go. What I want to say. We present a framework where an information seller sells information, designs an auction to sell information to buyers who are competing in a downstream market. Buyers try to match their action with the state, and we want to see what is the optimal auction for maximizing revenue, maximizing welfare. How does this optimal auction changes based on the intensity of the competition between the firms, and intensity of the competition between the firms. We want to see so intensity of competition between the firms, and how exclusive data. That's it. That's the main result that is what I want to show. So you can see that when we increase alpha, which stands for the intensity of competition, the area which we sell exclusive data increases. However, for whoever you are, you still need to get some information to satisfy your obedience. Otherwise, they don't care about your information. And you can see this V star line that says whatever it is, user 1, however his value is, will receive some level of right information. Unless V2 is much higher, then he will receive exclusive content. And in between, they both receive information, but if intensity is too much that they are hurting each other, if they both take right action, the result will be empty. None of them with the right action. How long was it? I don't know. Alright, let's go for 2 minutes now. What is this? Let's go timer or stopwatch. Alright. It is more like abstract than this. I felt that is the scheme. So it's like abstract. You give me abstract, you want to tell me what to do. Yeah, it's more of that. So, I mean, if it was up to me, if I wanted to be more clear on the game, I would put the table first. But it is not, so. Let's go. Let's go again. Ah! It is scary. Alright, what do I want to say? So we study a setup where information is being sold to two buyers. I hate these buyers. So, okay, information is being sold to two buyers who are in competition, and one buyer taking right action will hurt the other one. We want to sell this data through auction. We want to see what optimal auction look like for maximizing revenue or maximizing welfare, and we want to see how it changes when we change the intensity of the competition between the buyers. Should we sell more exclusive data, low exclusive data? And in order for selling data to work, we show that we cannot all the time lie to them. So we have to tell them the truth at least for some portion of the time. This is the optimal auction for welfare. You can see that when one of them is much higher value than the other, he only receives buyer 2 is higher value than the higher buyer 1. He only receives the right action recommendation, while if they are too close to each other, they both receive right action recommendation. And when user 1 similar to and when we increase it to alpha equals 3/2, then we see that even if they are very close, we don't tell them the right action because it hurts the society as a whole. And you can see that in both cases we have to provide obedience, giving the right action recommendation to user 1 for a portion of the time. Up to this horizontal line, we have to give user 1, otherwise he won't listen us and he won't trust us. Well, actually it was 2 and 10. That was good. Should I write it down? I fucking hate writing down. At least I want to say what is it. I'll find out how it's optimally affected by condition. Oh. Honestly, I think I can skip the first. I can skip the first part, like first slide. I cannot skip. I can spend less time on the first slide and more time on the second. So if that's a good part, right? Because we are focusing on showing the result and result in the second part. So that's what I want to do. So are you ready? So the paper studies a game of incomplete information. A data seller has extra information about the environment where two buyers are competing against each other in a downstream market. The paper tries to come up with a model to model. I hate this sentence. Okay. The paper is introduces a model to sell information through auction to these firms. They have their own private data about their valuation and profitability, and we want to find the optimal auction to maximize revenue, to maximize welfare, how it looks like, and how it changes based on the intensity between the buyers. All right. We want to make sure buyers follow our action recommendation, the seller's action recommendation, so they require to receive the truth at least some part of the time. And this is the fucking optimal auction. You can see that when on the left hand side, when the competition level is lower, alpha is 2/3, it stands for competition level. You can see that when user 2 above this curve, I don't know how to name it actually, above this curve, horizontal line and the ray, only user 2 receives the right action, exclusive. In between, both of them receive the right action. But when the competition level becomes higher, you can see that user 2 receives more exclusive content, right action recommendation. However, user 1 still receives right action recommendation up to V star, so that the obedience is met, and there are areas that none of them get the right action recommendation. Okay, I think if I remove that, it will be good. By the way, it's my paper. I can talk about it forever. I don't know how it is. Is it like, are we going to, I can get in more details about these plots. I want to know, am I talking forever and they stop me at 2 minutes, or it is, alright, start. I don't know, are we making a TikTok video? I'm a podcast guy. Alright, let's make it more exciting this time. I'm gonna set the timer. Alright, So this paper studies a model where data is being sold to two buyers who are in competition against each other in a downstream market over the market share, and the seller has extra information about the market and can recommend these buyers to take the right or wrong actions. However, the seller has to make sure they follow their recommended action. Therefore, there are some obedience constraints. And now we want to sell this data through an auction setup. What is the optimal auction? Is it welfare optimal or is it revenue optimal? And how it changes, how optimal auction changes based on the level of the intensity of competition between the buyers. So we will go, this is the fucking this is the optimal auction. You can see that on the left hand side, it is the optimal for welfare when intensity is low, and the right hand side, intensity is higher. You can see that above that curve, user 2 has higher value than compared to user 1, so he receives the exclusive right action. User 1 receives wrong action. Actually, in between, when they are close, both of them receive right action. And similar for user 1, on the right hand side, when the intensity of the competition is higher, you can see extra exclusive content for user 2 and lower right action for both, especially when they're both high value. When they are close to each other, we give both of them wrong action recommendation because they will hurt each other and it will be bad for the society. Alright, so it was... Okay, I could go more. Until get the fucking... I had extra 10 seconds. I don't know how to present it because they don't know anything about the game. Do you want me... I don't think it's a good idea. It's a good idea to go talk about the game, and it is a matching game. Each buyer, you need to match their action with the state. Binary, I add a lot of words, but I don't think if the receiver can digest all of them at the same time. Like, it is too much for them. And I don't want to talk fast. You should not talk fast. This is bad. Actually, 2 minutes is too much time. You know what? Let's go on a slow mode this time. Ready? Guys, if you watch this video, pray for me. Even if you don't believe in anything, like I do. So, aim. So we want to find the optimal revenue and welfare auction, and that's actually just, yeah, I think we can auction for data and see how it changes when we compare, when we change the intensity of competition. That's actually really good. I don't need to go, it is an auction. I mean, auction in general, it is abstract enough so that I remove all the details about the game, and it says, alright, everybody knows what auction is. So we want to sell auction. We want to sell data through auction to two firms that are in competition against each other, and this data helps them. we want to find the optimal auction for maximizing revenue or welfare, and we want to see how it changes when we change the intensity of the competition. So you can see on the left graph we have lower intensity competition, alpha. Competition intensity is alpha 2/3, while on the right one we increase it to 3/2. On the left hand side you can see that when user 2 is higher than user 1, value of user 2 is much higher than user 1, they receive exclusive information, while if they are close to each other, both of them receive the information, and if user 1 is higher, okay, similar for user 1. On the right hand side you can see that when alpha increases, this exclusive area increases by increasing intensity. So exclusive information assignment increases, the area increases, and you can see that there are areas that none of them get the right information because they're too close to each other, and there are areas that both of them need to. There is a minimum area that both of them, which is the horizontal and vertical line, both of them need to receive minimum amount of right information in order to keep the auction incentive compatible. That's it. Alright, I have repeated it so many times. Give me some time. Also, I have to become TA next semester. Oh, so many times. Alright, let's just finish the next 5 hours. Let's, for now, focus on that. Other things later. I don't wanna think about what happens after 5 hours from now. For me, today is just about up to 5 p.m. The rest some other time. So let's go. I think actually I'm good. Yeah, we did 2 minutes. So this paper studies, fuck this, I hate that. I always hate this start. In this paper we study how to sell data through an auction to the firms that are in competition against each other in a downstream market. We want to find the optimal auction for maximizing revenue and welfare, and we want to see how it changes, the optimal auction changes based on the intensity of the competition among the buyers, between the buyers. So you can see that we found the optimal auction, the allocation rule here, when one user is much higher value than the other user, they receive exclusive information. When they are close to each other on the left hand side, both of them receive the right information. And on the right hand side, when we increase the intensity of the competition. You can see that the area where exclusive information, we allocate exclusive information, increases, and the area when even when they are high value but they are close to each other, um, none of them receive the right information. In both plots, we still need to make them trust us and the mechanism to be incentive compatible. So regardless of the intensity of competition, they will receive right information up to V star in both cases, and um, and exclusive, incentive, right, left. Oh, I didn't start. That was like 2 minutes. All right, are you ready, guys? I just said oh. How many rounds did I say? All right, let's do it one round here. So this paper studies how to sell data to firms that are in competition. I don't want to even look at the slides. Okay. I don't even want to look at the slides because I already have them in my head. So this paper studies how to sell data to two buyers who are in competition against each other, and we want to find the optimal auction to maximize revenue or welfare. And then we want to see how this auction changes when we change the intensity of the competition between the buyers. Then we go to the next slide. On the left hand side, you can see the intensity of competition is lower, right hand side higher. Alpha stands for the intensity of competition, so we increase, and you can see above the curve, the graph, when user 2 has much higher value than user 1, we give user 2 exclusive information, access to information. Allocation will be exclusive to user 2. When they are close to each other, both of them receive the right information. And similar for user 1 when he is high value. Now, let's see what happens if we increase the intensity. We can see that the area where we allocate exclusive access to information increases. There are areas that users' valuations are close to each other, and we do not give any of them the right information. And still, in both cases, that's it. Even I don't even need to talk about it. So that's pretty good. Oh. Alright, this is over. I'm doing it too much, too many times. Alright, we do 3 more rounds and we are good to go. I think I don't want to. What is the aim? What is the optimal auction for revenue and welfare? What is the what is it? We aim to that, and then what is the other one? What do you want to show? I don't know, something like that. Aim is finding the optimal auction for revenue and welfare. Finding the optimal revenue for revenue and welfare. Optimal auction for revenue and welfare. And then we want to show how it changes. Optimal revenue changes. Optimal auction changes when we change intensity of competition. And then next page it is the 2 graphs. Obedience, fuck obedience, exclusive allocation, and increase in the exclusive content. Pretty good. Alright, this time I will talk like this. So, this paper, okay, it is you, alright. This paper studies optimal auction on how to sell data to 2 firms that are in competition against each other. We find the optimal mechanism for selling data to maximize revenue and welfare, and we want to see how these optimal mechanisms change. I wish I just added welfare. How they change when we change the intensity of competition among the buyers. On the left hand side you can see, actually it is on the right hand side, it's my right hand, it's their left hand. On the left hand side you can see the allocation rule when the competition is lower, less intense, and on the right hand side more intense. Alpha stands for intensity of competition. When user 2, above the curve, above this curve, you can see that trapezoid, it looks like a trapezoid. You can see that data buyer 2 has much higher value. Okay, what is the plot? On the x-axis we have valuation of user 1, on the y-axis we have valuation of user 2. You can see that in that part user 2 has much higher value than user 1, and he receives exclusive action recommendation, while when they are close in the between area region, both of them receive right action recommendation. When we compare it to the more intense competition case, you can see that the exclusive region increases by increasing alpha. Okay, that was not good. Dude, just 2 comparisons between alphas and how it is. First, like 30 seconds what a good allocation is, 30 seconds what is the other allocation. Simple. I think I need some water at this point. Yeah. I think it's good. You're good to go. I mean, this is where I work. We have elevator. Alright, I don't know.